Welcome everybody, and I'm very happy to be here for this webinar hosted by the Hydrogen Business for Climate Forum. A few weeks just before our forum, we have decided to organize a webinar because we're going to discuss a very exciting topic. You can hear about it almost every day, and very recently, because we're going to attend the Paris Motor Show, Alpine, which is a brand from the Renault Group, has just revealed a concept car powered by a combustion engine running on hydrogen. You can see it on the screen. It's Alpine Glow. So it's very interesting to see that a big brand such as Alpine from the Renault Group is just showcasing a car powered by hydrogen with a conventional combustion engine. So this is the reason why we have decided to organize this webinar today. And again, it's just an appetizer because it's a topic we're going to address during the forum in November. So we have decided to give a name to this webinar, and is hydrogen combustion engine, is this the new holy grail? This is a question we're going to ask with our speakers. You're going to discover just in a few seconds who is attending this webinar with me. So I have invited some speakers from ORECA MAGNY-COURS. ORECA is an engineering company in motorsports, and we welcome Loïc Combemale. So he's an engineer. Hello, Loïc. Thanks to be here today.
Hello, Laurent. Thank you.
I have invited also from BorgWarner. It's an OEM supplier, an American company, and he's just back from the US where he attended to a symposium on hydrogen. So it's Jean Luc Beduneau. Hello, Jean Luc.
Hello, Laurent. Hello, Loïc. Thanks for your invitation, and I hope that it will be an instructive exchange.
Yes, so you're the Director of Innovation. Also around the table, we have from Solution F, which is a company involved in engines and belonging to the GCK group, Vincent Lallemand. Hello, Vincent.
Hello, Laurent. Thank you to welcome us.
Thanks to be here. We have Fabrice Foucher from the University of Orléans. He's head of the H2 projects for the laboratory Prisme, working for 20 years now on this topic. Hello, Fabrice. Thanks to be here.
Hello, Laurent. Hello, everyone.
And last but not least, from the Cluster Vehicle of the Future, Bruno Jamet. I remind just that the Vehicle of the Future cluster is the organizer of the forum. Hello, Bruno.
Hello, Laurent. Hello, everyone.
Okay, so Bruno, we're going to start with you because, as I said, the Cluster Vehicle of the Future is the organizer of this forum. And maybe just to remind what is this event taking place on November 8th and 9th, what is the philosophy of this forum?
So the philosophy is to include both high-level plenary sessions and also innovation labs. So for the plenary sessions, it will be as close as possible to current events, taking into account the climate, economics, and geopolitical context. And we will have 5 plenary sessions. The first one is about imports and mass production of hydrogen, with the global overview and potential links worldwide with North Africa, South America, and also Southern Europe, like Spain and Portugal, which have significant renewable energy potential. The second one is the territorial ecosystems. The third one is the European future hydrogen champions, like IPCEI projects, important projects of common European interest. The fourth one is industry as a locomotive. And the last one is a synthesis of the different innovation labs. And it will be an opportunity to do business with B2B meetings and also enjoy visits such as FC Lab and GOSA. And I can talk later about the labs if you want.
Yes, so as you said, we can find some innovation labs, 3 in total, and one of them is dedicated to mobility. And this topic of combustion engines running on hydrogen will be addressed in this session.
Yes, exactly. In fact, technological neutrality of Pôle Véhicule du Futur has been always the case, and we consider that internal combustion engines with hydrogen is a very good solution for many applications.
Maybe a question for our speakers today. Are you interested to participate to this workshop and maybe contribute after this webinar?
Yes, from BorgWarner side, we will be part of this Congress. We need to organize ourselves to make sure that we'll have the right attendance, because there's quite a lot going on such field. But yes, we'll participate to this interesting Congress. Yes.
That's great. It's still time to participate to these innovation labs and for the forum, of course. Maybe a word again with you, Bruno. You have some clients at the Pôle Véhicule du Futur, some companies. Are they working on this topic, on this technology of the combustion engine running on e-fuels or hydrogen?
Yes, for sure. In fact, we hear a lot about batteries and hydrogen with fuel cells, but in fact, there is a very diversified mix of powertrain solutions. Each of them is optimized for the use case and the special vehicle you consider. So yes, many projects, and also many projects amongst our members like ORECA.
Okay, so gentlemen, let's start the conversation. I would like first to talk with Jean Luc Beduneau. So you're just back from the US, where you attended to a symposium on hydrogen. Maybe a few words about this event. What's the climate like in the US concerning hydrogen?
Huge momentum on hydrogen. So yeah, it was very interesting congress, perhaps biggest one since a while on hydrogen, where was shared really all the new information given from the government to promote hydrogen, green hydrogen, of course, on top of this, but hydrogen globally as a way to reduce our carbon emissions. So yeah, it was very interesting. More than 500 people, I think close to 800 were attending live or through video. So it was very great. And yeah, you can feel that, as you know, US is used to do a lot of momentum and passion on the things, and yeah, they will accelerate, and I think we'll see this even in Europe.
And what about the combustion engine with hydrogen? Is that the topic interesting American companies?
Yeah, there was a specific session on this topic where we participate as a company for BorgWarner. Yeah, it's really seen as a solution among others. So as was said just before, it's not that it's solve everything, and we need to adapt the solution to the different segment. But for mobility, yeah, for sure, there's a place for ISH2, and we are seeing this more and more. If you compare a few months or years ago, nobody was really looking on this, and now it's really on top of solution for certain segment.
So Jean-Luc, you're located in Blois, it's in center of France, and formerly the company was Delphi Diesel, so very specialized in injectors for diesel engines. And so the purpose, of course, is to keep the technological assets and to shift to a combustion with hydrogen instead of fossil fuels.
Yeah, so as usual, when you have to perform a change, what you need to try to avoid to have a disruption, because from disruption usually you have some important impact, and ISH2 can be really a way to switch from standard fossil fuel to hydrogen with, I would say, a smooth approach in terms of knowledge, asset, as you said, but also employment, because there's a lot of people working in this area. And for sure, keeping some hydrogen internal combustion will help to smooth this transition toward other solutions.
Okay, so a few words maybe about with Fabrice Foucher, because you're working closely together. Fabrice is working for a lab in Orléans. Orléans is rather close to Blois, and you're working together. So Fabrice, for many years, you've been focusing on combustion engines with hydrogen inside.
Yes, exactly. In fact, in our lab, we have several bench to study the combustion, but also some experimental setup to focus on more fundamental point of view. And so it's a really complementary, in fact, research activities. And it's for this reason that since a few years with BorgWarner, we try to move or to switch to more applications, in fact. So since 20 years, we study hydrogen, but also some other e-fuels or some other biofuels to decrease, in fact, the CO2 emissions. Sure. And because BorgWarner developed some ruptive hydrogen injector, we try to merge, in fact, our knowledge and our powerful teams to push as we can, in fact, the performance and the efficiency and the understandings about, in fact, the combustion and the hydrogen combustion in an engine.
And you're working with industrial companies. I just mentioned BorgWarner, but you're working also with trucks companies, for instance.
Yes, so we have several, in fact, projects with trucks, especially with Renault trucks. In Lyon, we develop, in fact, the combustion chamber for them, and the idea is to have in 2023 a demonstrator, a trucks demonstrator, with our concept of combustion chamber.
Okay, I have a first question about the efficiency of such an engine, and everybody can answer. I just remind that BMW 20 years ago just released a 7 Series hydrogen with a V12 engine running on hydrogen. It was with gasoline and hydrogen, by the way. We're just going to see a picture on your screen. So again, it was just 20 years ago. Veronique, if you can display this picture of the BMW. So that's it. Quite an impressive car, but the efficiency was not so good. So the question is, did we make some progress since this time? Who wants to speak first about this?
I can start. Perhaps first. Yeah, there was very important progress done on several areas that allowed now to reach an efficiency which is very, very close to what you can have today on diesel engine. But I will let Fabrice talk about this. So the main modifications that we've done since 20 years on engine are on different fields, and I will just look to the key ones. The first one is turbocharger. If you want to run with hydrogen, you will utilize this important flammability limit, important flame speed, leading to the ability to run with high excess of air. And this you can reach only with very efficient turbochargers that we have now available on the current vehicle. Another point is really direct injection. If you want to improve the combustion and to avoid to replace during the injection the air by the hydrogen, because if you inject through the plenum before your valve, of course you will replace. At the end, you need direct injection, and if you combine direct injection plus highly efficient turbocharger, you reach something which is very efficient and again close to what we can have today. And just last but not least, the fact that we made huge improvement on software and control. We can really have some real-time control with the current ECU in an engine. And if you want to manage the transient mode, because all our engines are very demanding in terms of transient, you can manage real time thanks to what has been done in software and control.
Of course, Vincent and Loïc can also give some comments. And maybe, do you remember this car? Did you see it already? Because it's been showcased in several exhibitions.
And it has been even in serial production. So yeah.
Yeah, of course. For limited production, I drove this car. So maybe Vincent, what do you think about this car?
Yeah, it was a first test, but today we have different solution. We are working. Solution Life is working on 2 hydrogen combustion engine approach. The easiest solution is to retrofit an existing engine. In this case, we estimate that the MCI efficiency should be around 35%. In the second case, if we design a new engine from scratch, we estimate that we could increase the engine efficiency to 47%. This is explained as the fact that the geometry of the combustion chambers, the shape of the cylinders heads, and the integration of the injectors must be specific for an hydrogen combustion engine. So it's very difficult to find an engine that already has the ideal geometric characteristic for this specific use case. And I think that in the case of the BMW, maybe that the engine was not exactly the best case to do this conversion.
I would like to add something, is that it was a V12, it was not supercharged, and as it was a very large V12, the working point were at quite low load in terms of pressure. So it's a very bad use case for a good internal combustion engine efficiency. And very modern engines, not depending on the fuel you use, either gasoline, diesel, etc., have a supercharged system and have a lower displacement compared to the specific power.
So
Okay,
very important. BMW didn't make any mistake. It's just that, as you said, at this time, technology was not really available to reach what was highlighted.
Yes, it was the beginning.
Sure. I would like now to switch to competition, and I would like to ask some questions to Loïc Combemale from ORECA MAGNY-COURS. First, about the efficiency of engines in competition. I heard that in Formula One, it was around 50%, which is quite impressive today.
Yes, for sure. In Formula One, which is, I would say, the highest lab for combustion development, they are reaching a very high level of efficiency. They are, I would say, controlling everything, looking to the combustion in real time. So for sure, they are able to reach very high efficiency for a gasoline engine.
So let's see now what is ORECA MAGNY-COURS doing, because you decided to go into the combustion engines with hydrogen. And what about, I would say, the regulation in different categories of motorsport? Is it open to such an engine?
So today, it's clear that the, I would say, roadmap of the FIA is to open competition to new technology and trying to have a green technology. Today, they are willing to have some hydrogen technology, electric. There is already some Formula E or Rallycross Rallycross for electric. But this year, the ASO, the organization of Dakar, clearly shows a roadmap that they will open competition for hydrogen engine or fuel cell. Still today, there is no clear regulation about hydrogen. They, I guess, wait to have, I would say, some first experience to see how they will be able to specify the regulation, especially for the safety.
Anyways, you're working on such an engine for the Dakar, and just tell us how you're working, because you've got all the expertise, of course, to design an engine, and you have also a partner, which is FEV Group.
Yes, exactly. So I would say, as we know that the combustion of hydrogen is completely different than on the gasoline engine, we decided to approach FEV in order to cooperate on the combustion development of the combustion for our engine. So we make several studies about the engine itself. We will use one of our specific engine that we already designed here internally, and that we will adapt in order to be able to run with hydrogen.
Thank you. I have a question about the Dakar for Vincent Lallemand from Solution F, because GCK is going to participate to the Dakar, but with a buggy and with a fuel cell at the moment.
Yes, we have started our Green Rally race program with a fuel cell. We already know this technology, and we have designed a new high-power fuel cell, which is unique because of this power level. Indeed, this fuel cell is able to produce a maximum power of more than 170 kilowatt. And we took advantage of our expertise for the storage of hydrogen at 700 bar. But we are thinking in parallel about the development of a high-power hydrogen engine for this type of application, because this solution could solve several problems, as the pollution with the dust and the vibration and shock resistance. That is why that today we have a program to design a new engine for this application, but it's the beginning for us. We continue our design of our fuel cell and the integration of hydrogen in our prototype, but we have this project to use a new engine for this application yet.
This is a question to the experts of competition, such as Vincent, of course, but Loïc as well. Can we imagine some combustion engines running on hydrogen for Formula One in the future? Because the regulation is going to change in 2026, and I already read several times that Laurent Rossi, the CEO from Alpine, was pushing towards such a technology, for instance.
I would say, for me, nothing is impossible. I would say, I guess, for sure, Formula One or Endurance are the biggest, as I said, lab for new technology.
And of course, the same question applies for 24 Hours of Le Mans.
So why not? I would say everything is possible, just depending of what will do the regulation.
And Fabrice or Jean-Luc, I don't know if you're familiar with competition, but it's a test bench. So that's the ideal place to see if the engine gives performance. So what do you think of all this?
For my part, I think if internal combustion engine running with hydrogen will come from the heavy duty or off-road, and in the opposite way, in fact, from the race. Perhaps, in fact, this kind of applications will be very fun, and the demonstration could be done to prove that we can have the same performance as a gasoline engine, and with the fun of the internal combustion engine. So let's see. I don't know.
And Jean-Luc, do you have some comments about this competition, and that place you would like to enter?
Yeah, so I think more or less as Loïc will not say everything, but the point is that for me, at one of time, we'll need the end user acceptance also, because today, ICE is not really seen as the best ever solution to decarbonize, perhaps sometimes because it's not clearly explained that the issue is not really the technology of ICE, but it's more what you have as a fuel. But we all know that racing is really a very good way to promote the technology. And Loïc said this is a very good laboratory, but it's also something where people can recognize themselves. And if they see how efficient it can be, and if they see the champions and the team working with it, at the end it's easier for them to buy such technology. So both ways, technology to accelerate, improve, and aside this, perhaps it's the fact that it will really help for the acceptance.
I just gave a comment about the Alpine concept car. Was referring at the beginning of this webinar. Alpine says we want to keep the sound of the engine. So you got the emotion. Of course, you just have water coming from the pipe, but you have still the sound and the vibration, which is from part of the DNA in competition. Okay, so that's it for competition. But I would like now
if I can comment for the competition, I think that hydrogen MCA could be a good solution, and we have started a project of hyper engines that could be used for such an application. But today, for this type of race, I think that the main problem is quick refueling and the storage of hydrogen in the vehicle. to be able to have a long range, we need a very big tanks, and it's not so easy to integrate them in the car. So that's why I think that the efficiency of the engine is the best challenge today, because more than the maximum power, because the more efficiency is, less we need hydrogen. And I think that is the problem today, is the tank and the storage.
Yes, of course. Maybe we'll come back later to this issue. But I would like now to discuss the pollution, because we discussed efficiency. So I understand that there has been a huge progress since 20 years, but still we have some NOx, we have some pollution. So what about this? Can we solve this issue? Who wants to start first? Because it's a big question, the pollution.
Maybe I can start from the first approach. The emissions like NOx, it's the main question, because emissions from oil burning from the crankcase, it's something very negligible, and it cannot be changed a lot. About NOx, some people imagine to run lean and so reduce the flame temperature and therefore have lower NOx, even without after treatment. And other companies imagine to add water in the combustion chamber to reduce the temperature and therefore the NOx and also the knocking levels. So there are also other solutions, but I will leave the floor to the other speakers.
Okay, who wants to give some other comments?
For me, an important point on this is that we have all technology required to address this. So it's not really something that is seen as a roadblock. So there was shared different solution, water injection, run very lean, SCR to kill what NOx remain. For us, what will be important to convince people, because again, for me, the acceptance will be key, not only for end user, but for example, European Commission. We need to bring results on. We are working, for example, with Fabrice on a demo vehicle, and the purpose of this demo vehicle is, of course, to show how it works and the performance, but it's also to go up to the point that we can have real measurement level to see that this is where we are. So after we can start the debate that it's not perfect, it's not zero, and so, but I've not really seen a regulation where you have zero. If you have some in your food, if you have some specific compound, you will always find traces, but at the end, there's a benefit. So it's for me, emission is something that we'll manage. I don't want to say easy, but we have all technology to do so.
So does that mean you have to bring some new tools for the EU just in order to measure or to prove that the combustion is rather right and not so harmful?
Yeah, so I had a meeting, so it was 2 weeks ago with European Parliament people, and we'll be back to Brussels next week. And they are looking on real measurement, because they are reaching also the limit of the tools that exist, and they need also to define new tools to be able to measure the very low level of CO2 NOx that you can find in the exhaust. So perhaps Fabrice, you will tell more, because you even develop some specific technologies, but they are at this point that they need facts and vehicle to develop the tool.
Okay, Bruno, about the acceptance of the European Commission, it's key, because of course today we can see that all the car makers are going to full electric, but of course we know that they had technical leadership on engines, and so maybe it's there is some room to keep that advantage compared to Asia and especially China.
Yes, in fact, what's important is the facts, as Jean-Luc told. And so the emissions, it's not an issue. There is technology available. The efficiency also, it's important to mention that internal combustion engines can have, in many applications, a higher efficiency than fuel cells. Because this is not the same powertrain characteristics. In a fuel cell, you have an average peak efficiency around half the maximum power, or maybe 1/3. And in an internal combustion engine, it's at a very high load, or maybe average to high load. And so if you use a powertrain, a vehicle in high load conditions, the internal combustion engine has a higher efficiency. In the mining project, we are over 55%. In some trucks, over 45, or in a race cars, maybe over 50%. And at the opposite, if you use a fuel cell in a race car at very high loads, the fuel cell with at the system level will maybe have an efficiency lower than 40 or 35% due to cooling issues, etc. So we have to be very pragmatic, and in many cases, the efficiency is really higher, and so the cost, the use cost is higher. And Alpine told, okay, it's for the noise, but in a race car or in a sport car, it can be also a reliable pleasure and lower fuel, lower H2 consumption. Very pragmatic.
In competition, of course, what you're looking at is performance, speed for the car, and so on. So, do you look at the pollutants such as NOx when you develop your engine?
No, I would say in general in competition we are not looking so much to. For sure, we know that in our application, if we will want to have some power from the engine, at one point we will need to, I would say, go more side than the lean side. So for sure, we will run leaner than what we are used to with a gasoline engine. Still, we know that we will, I would say, have temperatures than what will be in a normal car in the future if there is some hydrogen engine. So yes, for sure, we will have some NOx. This we will not, I would say, be out of.
Okay, so let's see now what could be the use cases for such a combustion engine powered by hydrogen. Can we imagine this on for road cars or LCVs? We start with you, Jean Luc, because you have some LCVs running around BorgWarner. We can already see them on the road.
Yeah. Yeah, it's interesting, and it was in Aachen this week, so it had quite a lot of success with people attending to this congress. So yeah, we are seeing so interest in different fields, and we are working on all the solutions we talked about, so battery electrical vehicle, fuel cell, and ICH2. We are really convinced at BorgWarner, and I'm used to say that there's a solution for each segment, because at the end, it was explained that sometimes you need to have high torque, sometimes you need to have long range, sometimes you need to run 50% of the efficiency of the engine, depending on what you need. And for sure, there are some solutions that cannot be found with BEV or fuel cell, for example, for off-highways vehicles. For off-highways vehicles that are really running in very difficult environments, it's difficult to have this very clean hydrogen. You can still manage perhaps, but for the air, this is where you to have issues with vibration, with all the dust, and so. So the robustness of hydrogen engine can make a lot of sense. And on LCV, it's more or less the same, slightly different, but you know that some people are really using those vehicles with long range, and they need to have the payload. They need to have on board more than 1 ton. And if you increase the weight of the vehicle coming from the powertrain too much, at the end, they don't have enough payload available for their own work. So they start to look to another type of vehicle, which is not anymore 3.5 ton, but perhaps above, which new driver license, and at the end, perhaps not their purpose.
So, Loïc, we mentioned, of course, the development of an engine for competition, and I just can say that this engine will be available at the forum Hydrogen Business for Climate as a demonstrator. The people visiting the forum will be able to see this engine. Are you working on other projects that Dakar or motorsports? Because you have some test bench and everything, which could be interesting for industrial companies.
No, for sure. Today we are focused on this Dakar engine. This is already taking a lot of time. Even if we are using, I would say, all our knowledge, and this is still mechanically, it's a conventional engine. Still, the combustion and the system injection is topic. So we are focused on it. for sure, we have our dyno which is ready to receive hydrogen or I would say hydrogen engine or fuel cell. So for sure, if someone will be I would say willing to make this, we will be happy to do it.
Vincent, at Solution F, inside the GCK group, what kind of application for this combustion engine on hydrogen? Road transports, maybe other modes?
Yes, we think that for big engine with high value, the hydrogen retrofit is the solution. We have no fuel cell available today for very high power application. For me, high power application is over than 500 kilowatts. So for the bus or off-road vehicles is the solution. For the road use, the main problem is the homologation. We are specialized in retrofit, and today in France, we have no regulation allowing such a transformation. That is a problem today.
Okay, and what about
Laurent, if I can, for me, regulation is really the biggest hurdles we are facing today. So you talked about retrofit. It's correct that it's not clear, even if there was some progress allowing to have this retrofit of vehicle after 3 years or 5 years. But yeah, we need really to have a push from European Parliament for standard vehicle and for retrofit. It's more at France level that we need to have this push to have really the border defined. Otherwise, we will not succeed to progress on a very important solution.
That's right, and the key players of retrofit will be at the Paris Motor Show next week. So maybe it would be an opportunity to discuss and to convince them and the government, of course, to introduce NCI H2 in the regulation. So I was just mentioning, my question was about planes, because I read that Airbus wanted to make a test with a combustion engine in a big plane. So do you think it could be possible in the future?
In fact, I can give some figures about it. I discussed recently with some presidents of planes companies. For little planes, I know some projects where fuel cell has been studied, and it was abandoned due to the mass of the fuel cell, its size, but also the mass needed to cool the fuel cell. Because when you have an internal combustion engine, the temperature is extracted a lot through the exhaust. In a fuel cell, you need to cool everything, 50 to 60% of the energy contained in the hydrogen. If you talk about commercial planes like A320 or Boeing equivalents, the specialists think that it won't be feasible for long trips. And the limit, they imagine it's not official. Maybe people won't like what I say, but what they think is that the limit will be between 50 and 60 planes. So the future for large planes maybe will be sustainable aviation fuels. But the quantity of the available quantity is the question now. That's my position.
We'll get to this point just in a few seconds. Maybe a question for Fabrice first about the trains, because we can see some trains running on fuel cells with Alstom in Germany and soon in France. Do you think it could be a solution to have some combustion engines, diesel one, retrofitted to hydrogen, maybe?
For me, I think it's the same as a truck. In fact, it could be more or less easy to modify the engine and run, in fact, this train with internal combustion engine with hydrogen. But you can have also other fuels. We speak about, in fact, the e-fuels. So sustainable fuels will be the solutions, as for example, ammonia or methanol. All these fuels could be made by using hydrogen and CO2 capture. So for when you need, in fact, a lot of energy storage, liquid fuels is more easy as gaseous fuels. So why not?
Okay, that's great because we come to the last part of this webinar. It's about synthetic fuels or e-fuels. And just before, because some people wonder about ammonia, so could it be a fuel instead of hydrogen in a combustion engine? This is a question for, of course, everyone.
It is. So we are working with Fabrice on both, but again, for me, different segment, different problem, different solution. And looking to the flame speed for ammonia on high transient engine with low displacement, as we are talking racing or even on trucks, it will be very difficult. Ships, you have already a lot of ammonia on port, and it was clearly a direction given in US that for big ships it will be such ammonia. There's other type of molecules, but yeah, again, different solution, different answer. Very important is to not push back some of them, otherwise we will not have solution to decarbonize on time what we are all intending to do.
Yeah, yes, this is very interesting because the approach has been to be very pragmatic. I worked with members of Pôle Véhicule du Futur on very large engines, and the issue was not the engine itself, but the storage. And so H2 storage was not possible at all. And so ammonia was studied and is working now. And it is no zero CO2 fuel, it is NH3, so you don't have this issue. And in terms of emissions, it is NOx, but NOx, we know how to deal with it, so it's not an issue also. So ammonia is a good solution in very large and heavy applications, but low speed applications.
But also when you, in fact, you have a problem of securities, in fact, imagine, in fact, for a mine engine. So it's impossible to apply or to have some hydrogen storage. So ammonia or other fuels could be, in fact, the solutions again.
And you mentioned methanol, and methanol they are studying to couple it with ammonia because of the quite poor characteristics of ammonia combustion. But methanol is posing a political solution because it includes carbon inside the molecule. But it's a political debate.
Yeah, so about the e-fuels, again, because we know that some car makers are working on that, Audi or Porsche, with a project in Chile with synthetic fuels made from CO2 and hydrogen. They want to put it in a racing car and maybe on the road in the future. Again, competition is an arena to make such tests. And Loïc, we can say that some categories already in motorsports run on synthetic fuels.
Yes, exactly. Yes, exactly. Endurance today is running with synthetic fuel. You have also the World Rally Championship, the WRC, which is using synthetic fuel, and the last one, not the last one, but one of also we know is Formula 4 in France, which is also using synthetic fuel. Yes.
Vincent, maybe a comment about synthetic fuels, either for road cars or for racing with combustion engines. Do you think it could be one of the solutions? Is Vincent hearing me? I'm not sure.
Oh, I'm not sure.
I think he may have a connection problem.
Well, maybe I can add something. There is always the question of the primary energy, because in hydrogen there was been the debate about efficiency of the complete chain, and also in the e-fuels there is the question of the primary energy you need to get the final energy inside the e-fuel, and that's a question for the moment. And for the moment, the unit. The cost of 1 liter of e-fuel is quite high for maybe this reason, and also industrial reasons.
Well, gentlemen, when you can read in the news that some more and more companies are working on combustion engines running on hydrogen, so you feel confident about this technology? You think there is room for the future, and you have to go forward and maybe accelerate?
Yeah, we need to accelerate now. If the regulation is coming, I can tell you everybody will be ready to do so. Now it's really a matter of speed, not only because we need to reduce our impact linked to CO2 in our emission because the planet requires this, but it's also the fact that if we delay too much, the knowledge will disappear somehow, because with all new regulation and so battery electrical vehicle and other type of technologies, the industry is pushing towards those directions. So, and they cannot do everything in parallel at the same speed if they don't have a clear view for the future. It's people will like or dislike, but at one of time, looking to big industry and big volume, it's really a matter of investment. And you will never have investment if you don't have some certainty in terms of future. So regulation is really key, and people need to understand this, that we are really at the shift time that either we'll go, but in 2 years time for me it would be too late, and at least too late in Europe, because other region perhaps will remain with the know-how, but in Europe we'll have lost this one.
Well, if I have to sum up, because we come to the end of this webinar, so the technology is ready, efficient, we can solve the pollution problem, and we need now to convince the authorities for regulation and even for retrofit. So maybe to conclude, Bruno, what's your feeling? We need to talk more and more to just in order to convince people that this is the solution. It's viable.
Yes, in fact, I talked about techno neutrality. That's very important to take the good decisions. And for the moment, internal combustion engines are not well considered, and it is a sad situation, as Jean Luc told. But what is important to know is that with an affordable solution, such as internal combustion engines, you will have a very large and fast deployment of low or close to zero emissions vehicles. And so you will move really faster to the complete fleet decarbonization. And if you want to wait many years to be perfect, you will wait a long time. So that's very important to consider internal combustion engines also as a key to move faster for the climate. This is something we will talk about during the Mobility Lab we mentioned earlier. And in the Mobility Lab, we will move to 2035 in a world where hydrogen has expanded far more than expected in 2022. And then we will do a backcasting that will take us in 2022 to identify what's changed, what were the key to success hydrogen.
So please come and subscribe to this forum and come to attend also to the Innovation Labs. Thanks again, gentlemen, for being part of this talk, of this show. I would like to thank again Jean Luc Beduneau from BorgWarner, Vincent Lallemand from Solution F, Fabrice Foucher from the University of Orléans, Laboratory Prisme, and of course Loïc Combemale from ORECA MAGNY-COURS, and Bruno Jamet for Véhicule du Futur, the cluster which is the organizer of this forum. Thank you, gentlemen. Maybe to conclude on my side, I would like to say just a few words about the forum. So please come and visit it, because you're going to hear from high-level speakers for plenary sessions, for, of course, the labs, as we say, innovation labs, and you will be able to see as well some vehicles. For instance, you will be able to see the H2 racing truck from Gossin, which has participated to the Dakar earlier this year. So it's a fuel cell powered vehicle, and maybe one of these days Gossin will be able to race at the 24 hours of Le Mans for the trucks series with a fuel cell, not with a combustion engine. The combustion engine from ORECA will be visible on site, of course, and many other things to discover, such as the first H2 powered motorbike, which will be built in the Magny-Cours area with H2 Motronics, for instance. So again, don't forget to visit us and to subscribe to this forum, Hydrogen Business for Climate. See you very soon. Bye-bye.
Thank you.
Thanks a lot. Bye.